For millennia, humans have stared up at the cosmos, searching for answers. But what if I told you some of the universe's most incredible secrets are right here on Earth, hidden in plain sight? We often think of physics as equations on a chalkboard or complex theories confined to textbooks. But the truth is, physics is alive. It's in the way a bird soars through the air, the way a tree bends in the wind, the way a single drop of water can refract light into a dazzling rainbow. So buckle up, because today, we're diving headfirst into the wonders of the universe, exploring 5 physics phenomena that will leave you questioning everything you thought you knew. Imagine a world where objects could float effortlessly, defying gravity's pull. Well, what if I told you this futuristic concept is already a reality, thanks to the mind-bending world of quantum mechanics? Let me introduce you to quantum levitation, a phenomenon where superconductors, materials that conduct electricity with zero resistance, can become locked in a magnetic field, essentially levitating in midair. Picture this: a small, disc-shaped superconductor bathed in the ethereal glow of liquid nitrogen. As it chills to an astonishing -321 degrees Fahrenheit, it undergoes a remarkable transformation. It becomes a superconductor, capable of repelling magnetic fields with extraordinary strength. This creates a force strong enough to counteract gravity, causing the superconductor to levitate, seemingly suspended in mid-air. Quantum levitation has the potential to revolutionize transportation. Imagine frictionless trains gliding effortlessly above magnetic tracks at incredible speeds. That's the promise of maglev technology, a real-world application of this mind-blowing phenomenon. Time, that relentless river flowing inexorably forward, always at the same pace. Or is it? Einstein's theory of relativity threw a cosmic curveball into our understanding of time, revealing that it's not as constant as we once believed. Time dilation, a mind-bending consequence of relativity, suggests that time can actually speed up or slow down depending on your relative motion. The faster you travel through space, the slower time passes for you compared to someone standing still. Imagine 2 identical clocks, synchronized to perfection. One remains here on Earth, ticking away at its familiar pace. The other embarks on a high-speed journey aboard a spacecraft, hurtling through the cosmos at a significant fraction of the speed of light. As the spacecraft approaches the speed of light, time on board begins to slow down relative to time on Earth. This isn't science fiction, it's a real phenomenon, observed in experiments with atomic clocks flown on high-speed jets. We encounter fluids every day: water flowing from a faucet, honey drizzling from a spoon, air rushing past as we walk. But what if I told you there's a class of fluids so bizarre, so counterintuitive, they seem to defy the very laws of physics? Enter the strange world of non-Newtonian fluids, substances that refuse to play by the rules. Unlike their ordinary counterparts, their viscosity, their resistance to flow, changes dramatically under stress. One of the most fascinating examples is oobleck, a simple mixture of cornstarch and water that behaves like a liquid one moment and a solid the next. Pour it gently, and it flows like water. But try to punch it, and it instantly transforms into a solid, resisting your force. This unusual behavior arises from the cornstarch particles suspended in the water. When subjected to sudden stress, these particles jam together, creating a temporary solid structure. Non-Newtonian fluids aren't just curiosities, they have real-world applications, from body armor that hardens on impact, to shock absorbers that adapt to changing road conditions. Prepare to enter the realm of quantum entanglement, where the universe reveals its truly bizarre nature. Imagine 2 particles, linked together in a way that defies our everyday intuition. They're not physically connected, yet they share a mysterious invisible bond. Change the state of one particle, say, by measuring its spin, and instantaneously the other particle, no matter how far away, will also change its state in a predictable way. It's as if they're communicating faster than the speed of light, instantaneously aware of each other's every move. Einstein himself called this spooky action at a distance, and for good reason. Quantum entanglement is more than just a theoretical curiosity. It's the foundation for a new generation of technologies, including quantum computers. Imagine a computer that can perform calculations millions of times faster than today's most powerful supercomputers, all thanks to the mind-bending phenomenon of entanglement. We all know that heat makes things hotter and cold makes things colder, right? It's basic thermodynamics. But what if I told you there's a situation where hot water can actually freeze faster than cold water? Sounds counterintuitive, almost unbelievable, doesn't it? This is the Mpemba effect, named after a Tanzanian student who, in the 1960s, noticed that hot ice cream mixtures froze faster than colder ones. Imagine two identical containers filled with water, one hot and one cold, placed side by side in a freezer. You'd expect the cold water to freeze first, but sometimes, under the right conditions, the hot water can pull ahead, defying our everyday expectations. The exact mechanisms behind the Mpemba effect are still debated, but several theories attempt to explain this strange behavior. One suggests that evaporation plays a role, with the hot water losing mass more quickly, giving it a head start in the freezing race. Another theory proposes that convection currents within the hot water circulate heat more efficiently, cooling the overall volume faster. While the Mpemba effect has been observed and documented, it's not a universal law. It occurs under specific conditions, and replicating it consistently can be challenging. From the ethereal dance of quantum levitation to the mind-bending implications of time dilation, we've journeyed through a cosmos full of wonder and surprise. We've witnessed fluids defy logic, particles communicate instantaneously across vast distances, and hot water, against all odds, sometimes freeze faster than cold. The universe is a tapestry woven from the threads of physics, a grand symphony of forces and particles interacting in ways both elegant and bizarre. So keep questioning, keep exploring, and keep your sense of wonder alive. The universe is full of surprises, just waiting for curious minds to unlock its secrets. Which one shocked you the most? Comment below, and subscribe for more mind-blowing science.